All right. Hi there. This is video number 19. It is chapter 4, section 7. Oh, good Lord. I just butchered that. Okay, I can't even write. Chapter 4, section 7. And this is all about complex rational expressions. All right, so what that means, we know rational is a fraction. Complex means you have a fraction over a fraction. So I just want to remind you that means you have one fraction divided by another fraction, which is when you're going to utilize that strategy of keep the first one the same, change the division sign to multiplication, flip the second fraction upside down, or copy dot flop, whichever terminology or anything else you want to use. So we're going to start with some with numbers. I would highly advise you use no calculator so that when we get to the ones with variables, you're good. We're going to do 2 with numbers and 2 with variable, 3 with variables, and then done. So this is a pretty short, it's 1 page in my notes. And then we're done with the chapter. So here's our first example, and that's 3/4 over 2/5. Well, I would encourage you at the beginning to write these out, 3/4 divided by 2/5, and then do your keep change flip. So this is going to turn into keep it, change it, flip it. And then remember, when you multiply fractions, you multiply straight across. So this is 15 over 8. You can't reduce that, so you're done. That was easy, huh? All right, number 2. Looks like 1/3 minus 1/5. And again, I'm going to encourage you to do these without calculators so that you're doing them longhand. And then 1/4 plus 1/8. So I am going to create my equivalent fractions. Multiply this one by 3, multiply this one by 5. Multiply this one. I can make this one multiply by 2, and it will equal 8, so I don't actually have to multiply that one by anything. And my equivalent fractions are now 5/15 minus 3/15 over 2/8 minus 1/8. Simplify like terms. So I have 5 minus 3 is 2/15 over 1/8, which is 2/15 divided by 1/8, which is 2/15 times 8 over 1, which is 16 over 15. I just did something weird. Or I did something weird in my... Oh, I did do something weird. Look what I did. Okay, did anybody catch it? I made an error, sign error. I put a plus in here, and then I made this a minus. So this needs to be a plus. So this is not 1/8, but 3/8. So this is 3/8. So this is 8/3. So this is 45. Sorry about that. Minor inconvenience, but these things happen. We all know people copy stuff down wrong. I've seen it happen so many times. I've done it so many times. All right, now let's do a couple of problems. I have 3 of these that have variables in them, just to give you some experience with these. So here's example number 3. We have 1 minus 4 over a, that's a 4, over 1 plus 4 over a. All right, well, my 1 over 1, I'm going to turn each of these into an a over a. So I have a over a minus 4 over a, and a over a plus 4 over a. Combine these into a single fraction. So I have a minus 4 over a over a plus 4 over a. And then I'm going to just multiply and flip this. And kind of this is how I would do this on my paper. So I'm going to go times a over a plus 4, right? Which is the reciprocal of that. And then this is gone. And now I can cancel any like terms, so I can cancel these a's, and that leaves me a minus 4 over a plus 4, and don't you dare try to cancel those a's. You can't do that, right? Because they're added and subtracted. They're not multiplied, so that is the answer. Going back and reviewing, if I was to ask you, what is the domain of this? This is just bringing back past information. Don't forget, you set the denominator equal to 0 and solve. So these would be all x values not equal to -4. Because -4, if I put that in there, would make your denominator 0, which it can't be. And a can be any other value except -4. Okay, so that's one problem. Next, I have a squared minus 7a plus 10 over a squared plus 4a plus 3 over a squared minus 4a plus 4 over a squared plus 6a plus 9. So if you want to, you could actually do this. You could take and rewrite this first fraction. So I would have a squared minus 7a plus 10 over a squared plus 4a plus 3. And then take this and flip it right now times a squared plus 6a plus 9 over a squared minus 4a plus 4. And now factor everything and then cancel. So none of these a's, these should be easy for you guys to factor. I am not going to write the x methods out. I'm just going to do these. Top left, a squared minus 7a plus 10 is going to be a minus 5 and a minus 2. If you need to go and figure out what these all are, do that on your own paper. I'm not going to waste my time or yours. Underneath, a squared plus 4a plus 3 is a plus 3 times a plus 1. Times a squared plus 6a plus 9 is a plus 3 times a plus 3. You should be able to do these in your head like this, by the way. I don't have anything written down anywhere. And a squared minus 4a plus 4 is a minus 2 times a minus 2. And now cancel any common factors. So, excuse me, I can get rid of a minus 2 and an a minus 2. And only one top, because there's one on the bottom, right? So this one can't go anywhere. A plus 3 and an a plus 3. This one can't go anywhere. And nothing else will cancel out. So that leaves me as an answer a minus 5 times a plus 3 over a plus 1 times a minus 2. And just leave those in factored form. Do not remultiply these out together. You want to leave these factored. Okay? And then the last one we're going to do looks like this guy. 1 plus 1 over x minus 2 over 1 minus 1 over x minus 2. So this is a little similar to the 1 minus 4 over a, 1 plus 4 over a, just that when you turn these into like factors, this is going to be x minus 2 over x minus 2 plus 1 over x minus 2. This one will also turn into an x minus 2 over x minus 2 minus 1 over x minus 2. Now I can rewrite these as 1, so I have really x minus 2 plus 1, x minus 2 plus 1 in my numerator, and that turns into just x minus 1 over my denominator, which is x minus 2. That's just for the top here, right? And then the bottom, I have x minus 2 minus 1, which is x minus 3 over x minus 2. So I'm going to change and flip. So change an x minus 2 over x minus 3. My x minus 2s are going to cancel, leaving me x minus 1 over x minus 3. And that would be the answer to that guy. All right. So that finishes up chapter 4. And our next chapter is all about solving problems with exponential, exponential issues, I guess, and logarithms. So new stuff. It'll be fun. All right, toodaloo for now.